For Scientific American Science Quickly, I'm Rachel Feltman. With summer heat domes slamming down on parts of the U.S. and hurricane season ramping up, you've no doubt seen plenty of extreme weather stories in your feed over the last few weeks. Joining me today to demystify a few of those headlines is Andrea Thompson, a senior news editor for sustainability at Scientific American. Thanks so much for coming on to chat with us.
Thanks for having me.
So let's go over some of the topics that people might see trending in the headlines a lot, during this time of year. We'll start with flash flooding. Could you tell us a little bit about what happened in Texas and how it was possible for these floods to become so dangerous so quickly?
Yeah, so flash flood, it's, sort of in the name, it happens really quickly and often takes people by surprise. It happens when you have really intense rains over a fairly small area, usually over a relatively short time span. And that's basically what happened in Texas. There was between 6 to 10 inches of rain in 3 hours, which is a lot of rain. And basically the ground just can't absorb that much water that quickly. And it can be exacerbated by other aspects. In cities, you have a lot of pavement, a lot of asphalt, and those are impermeable to water. So water is going to collect even more than it would on, soil. And then topography can play a role too. And in Texas, this was an area with a lot of riverbeds, a lot of steep topography that basically funnels all that water down into one area. And in this case, in one spot in Hunt, Texas, the water rose 26 feet in 45 minutes on the Guadalupe River, which is just an incredible amount. And that's because there's just so much rain and it's all being funneled into sort of this one riverbed. And people just don't expect water to rise that much that quickly. And, for reference, 26 feet is more than 2 stories in a building. Water is also extremely powerful. Just 6 inches of quickly moving water can knock a person off their feet. And the faster the water is moving, the force increases faster than the water's actual velocity. So it's not exponential, but you're getting much more force even for every little step and velocity.
Yeah.
They're really hard to forecast, and that also takes people by surprise. So we can say it's going to rain in this area on this day, and pockets will have potentially big downpours like this. But you can't even say usually a few hours out, it's going to rain exactly this much in exactly this place, because these are such small features in the atmosphere that, weather models just can't pick them out that far in advance. So that also is an aspect in terms of people sort of being caught unawares.
Well, let's end on not a fun note for people who are experiencing it, but something that at least feels more fun to talk about. Everyone is Googling corn sweat. Everybody was talking about corn sweat last summer, and now corn sweat is back. So what is corn sweat, actually?
Yes, and it's not just the actor who's in the new Superman movie, which I've had lots of jokes about that. So basically, there are heat waves in the summer. They happen all the time. And some heat waves, especially if you're in, say, the western half of the country, they tend to be a drier heat. In the eastern half of the country, where it's wetter, you have a lot more humidity.
Swampy.
Yes. This is especially true around the Gulf Coast, where you have this really abundant source of warm, moist air from the Gulf of Mexico. The level of humidity can be affected by how wet a season has been. So we've had a pretty wet summer in the east, so everything is just really saturated with water. So when it's hot, there's a lot of water to evaporate or transpire from plants. And that's what's happening with corn and some other crops in the Midwest. These crops cover huge amounts of land. And when there's heat, they transpire water vapor into the air, and that raises the humidity. And they'd call it corn sweat, which is a very funny term, but very grabby. But the Midwest is kind of notorious for these really high humidity levels. Whereas when we think of humidity, we think of Florida or places like that. But no, the Midwest can get really humid in the summer because of this phenomenon.
Well, and I feel like I ask you about this almost every time you come on, but it hasn't stopped being important and useful. What can people do to keep cool in the summer and stay safe?
Absolutely. So one of the keys is sort of being aware of the level of risk for you or your loved ones, neighbors, young children, older people, people who take certain medications or have certain illnesses, especially heart disease, are more susceptible. People who work outside are much more susceptible to heat illness. So it's important to be particularly aware for those people. Generally, you want to avoid any strenuous activity outside in the middle of the day when the sun is at its highest and temperatures are at their highest. Staying hydrated, wearing loose clothing, light color clothing is really helpful. Being in the shade as much as possible. If you have access to air conditioning, being in that as much as possible. We actually also have a story on how to keep your home cool. And that includes, air conditioning is obviously kind of the gold standard in terms of keeping things comfortable. It also has the added benefit of pulling humidity out of the air. But there's a lot you can do with fans in terms of keeping a home relatively cool. And part of that is because the motion, the air currents that it generates means there's more air moving over the surface of your skin. So that is carrying heat away from your body, and it's also carrying sweat away, which sweat is basically the way our body naturally cools itself. So it's helping that process along. You can also do things like making sure to seal any drafts, making sure your windows are very nice and sealed. You can put up blackout blinds, or if you don't even have those, you can even just do good old-fashioned aluminum foil on the outside to reflect some of the solar heat. I've done a little bit of that myself in my apartment. And there are other tips like that to basically just minimize the amount of heat coming into your apartment and maximize the amount of cooling that is happening for you.
Well, thank you for that advice and for filling us in on these important issues in weather. And thanks so much for coming on to chat.
Thanks for having me.
That's all for today's episode. If you have any questions about the weather you'd like Andrea to answer for us in a future episode, let us know by sending us an email at sciencequickly@sciam.com. We'll be back on Friday with a fascinating conversation on the future of artificial intelligence and why you shouldn't necessarily freak out if your favorite chatbot starts talking about its own sentience. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi, Kelso, Harper, and Jeff DelViscio. This episode was edited by Alex Sugiura. Shayna, Posses, and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Rachel Feltman. See you next time.